Hello everyone, I hope you are doing well. I just want to say congratulations to the 2023 class of Maths Methods for completing their exam 1. I hope it went well. I had a lot of, I had to talk to some of my students and they told me that the exam was good, but, it had a lot of fractions, a lot of algebra and that. And so it kind of took too long, but yeah, I hope, you guys got your dream scores and stuff. Yeah, like always, guys, before I start the video, guys, if you guys want private tutoring, for example, you have sisters, brothers that are getting in year 12 or year 11, please, if you want tutoring for them, please, here's my email and you can email me through there. I can tutor you guys. Yeah, so, let's, smash through this. But luckily, I haven't actually had the PDF. I haven't actually got the PDF, but some of my students took pictures after the exams from their teachers. For example, when they finished their exams, they took pictures and they've sent it. So I've kind of put all those pictures, all the questions onto this PDF. And yeah, let's smash through this. Okay, so question 1. Let y equals this, find and simplify dy dx. So, okay, this is the quotient rule. So this is u and this is v. So, okay, so dy dx would be v, which is ex, the derivative of u, which is 2x minus 1, minus your x squared minus x, ex, all over e2x. So simplifying this, we get, taking the common factor of actual ex here, we get 2x minus 1 minus x squared minus x all over e2x. All right. So can you see how these are divided? So we can actually simplify them. We can simplify to, ex. So this will be 2x minus 1 minus x squared plus x. Alright, so minus x squared plus 3x minus 1 all over ex. This is your actual solution. Oh, it's very small, but yeah, that's that. Put that there. Oops, let me just take that there, put it right there. And yeah, this is your solution. Perfect. Next question. Let f of x be sine this. Find f dash pi on 4. Okay, 2 marks. So we have, okay, we need to find f dash of x. So f dash of x is, this is your u and this is your v. So we're going to use the product rule. So this is going to be sine x here. 2e2x plus e2x cos x. Okay, so then f dash pi on 4 will be, sine pi on 4 is 1 on root 2. 2e, so pi over 4 times 2 is just pi on 2. Plus e pi on 2. And cos pi on 4 is just, again, 1 on root 2. Now, we're going to rationalize this 1 over root 2. This will just be, root 2 on 2 times 2e pi on 2 plus, root 2 on 2 e pi on 2. Now, these two cancel out. So this is just root 2 e pi on 2 plus root 2 on 2 e pi on 2. So adding those together, we get 3 root 2 over 2 e pi on 2. Is that right? Okay, looks good. So yeah, 3 root 2 on 2 e pi on 4. Perfect. Pi on 2. So this should be for this solution. All right. Next question. Question 2, 3 marks. Solve e2x, this for x is an element of all reals. Okay, so e2x, I'm going to bring everything to the left. So this will be minus 4e x minus 12 equals 0. So I'm going to let actual u equal ex. So this over here is just ex squared minus 4ex minus 12 equals 0. So this will be u squared minus 4u minus 12 equals 0, which is just 62 minus here. So yeah, 2 minus 6, which is negative 4. Perfect. So u minus 6, u plus 2 equals 0, so u is actually equal to 6, and u is equal to -2. Now, we know that u is e to the x, so we're just going to say e to the x is actually equal to 6, or e to the x is equal to -2. Now, we're going to have to reject that ex, -2, because we know that ex is greater than 0. It cannot be a negative number, so we have to reject this. So, ex equals 6, so log e of 6 is actually equal to our x value. So yeah, this is your solution for this. So I'm just going to highlight it right over here. Perfect. Question 3, 4 marks. Sketch the graph of f of x, this on the axis below, so that's a rectangular hyperbola, labeling all asymptotes with the equations and axial intercepts with the coordinates. Yeah, I've tried to draw the kind of, that hopefully looks well and nice. So we know that there's going to be an asymptote at y equals 2. So I'm going to just draw a different color, make it nice. So this color, so y equals 2. There's going to be an asymptote at y equals 2. And there's going to be an asymptote at x equals 1. Okay, so that's that. And we know that, it's been reflected along the x-axis. So the graph is not going to look like this, but it's going to look like this. So, okay, we just find our y-intercept. So what's f of 0? That's 2 minus 3, -1, which is, 2 plus 3, which is 5. So our y-intercept is going to be over here. Perfect. Let me rub that out. And we know how the graph looks. We know it goes like this. So we're just going to beautifully trace down to it like that. Nicely. And we're going to label this point. So it's 0, 5. Perfect. Now we also need to label our x to find our x-intercept. So we're going to say what's f of x equals 0. That's going to be 2 equals 3x minus 1, which is 3 on 2. X minus 1, which is 3 on 2, plus 1 equals x, which is overall 5 on 2 is our x value. So 5 on 2 is 2.5, so it's around this part here. So this is going to look like this. Perfect. That's that, and then just rub that out, and let's also label that. So this point here is just 5 on 2, 0. Perfect, so have we done everything? Sketch the graph of f of x, labeling all asymptotes, yep, with the equations and axial intercepts with the coordinates. Okay, perfect. Find out values of x for which f of x is less than 1. Okay. So what I'm going to do is actually draw a line at y equals 1. So which is this point over here. So y equals 1 is this green graph, and f of x is this orange graph. So what we're saying is we want the orange graph to be less than the green graph. And when is it, when is it that? Well, we can see that it's pretty much less over this interval here. Yes? The orange graph is less than the green graph. So yeah, so it's less than that. So it's less, and which domain is it? Our x values? Well, we can see that x is going to be an element from this asymptote right over here, which is, 1, 2, this point over here, which is the point of intersection of this equation. So to do that, to find that point, we need to just solve. So if we know that f of x is that, so 2 minus 3 over x minus 1, we want to equate it to 1. So that will be 1 equals 3x minus 1. So 3 is equal to x minus 1, so x is equal to 4. So that point here is 4. Well, it's supposed to be around here, actually, but yeah. So it's supposed to be 4. So we can write it as 4, and we want to include it because this is being included, as you can see. So this is your answer. Let's rub that out. So x is an element from 1 to 4. Perfect. That's 1 mark. Just zoom it in. Alright, let's just, hopefully it's nice. Alright. So next question. Question 4. The graph of y equals x plus 1 over x is shown over the part of its domain. Okay. Use two trapeziums of equal width to approximate the area between the curve and x-axis and the line x equals 1 and x equals 3. So, this is what's happening. We're saying that at the line x equals 1, which is here, and x equals 3, we want to create two trapeziums. So, actually, these creates two trapeziums over here. So, your width is... each trapezium's width is 1, as shown here. So, and okay, and we're just going to draw these trapeziums. Okay, so now use the trapeziums of equal width to approximate the area between the graph and the x-axis and the line x. Okay, so yeah, to approximate it, the best way that I would write them is, okay, your area of the trapeziums is equal to, what's the width of each trapezium? It's 1, as you can see. So we're going to write 1. And we're going to put a bracket. When does it start? Well, we start over here and we end over here, the trapezium. So we start at this point here. So I'm going to try f of 1. Plus, what's the next line? Which is here. Because it's in the middle, anything that's between 1 and the 3, it's going to have twice f. So this will be 2 f of 2, as you can see. Plus, because this is at the end, we're just going to write f of 3 times, and at the end, don't forget the half, because remember, using the trapezium rule, we can't forget that half. So, all right, so we get this, and so we can say that a on t is 1. What's f of 1? Well, luckily we have the equation, so it's just 1, so it's 2 actually, as you can see. Plus, if you put 2, so 2 plus 1 over 2, which is 5 on 2, and times that, so that'll be 5 actually. That's good. What about what's f of 3? So 3 plus 1 on 3, 10 on 3. So this will be plus 10 on 3. Okay, let's rub that out. And we don't want to forget that times half, so I'm just going to put it over here. All right. So a on t is just 7 plus 10 on 3. What's that? 7, 14, 21. Plus 10 is 31 on 3. So this would be 31 on 3. Okay. And so a on t is 31 on 6. That's your actual solution. That's your area. We'll write units squared. Perfect. Done. Hope that's right. Okay, let's have a try at this question here. Question 4. So question 5. Evaluate this. Okay, this is nice. So we know that's going to be, to evaluate, this will be negative cos x from pi on 3 to 0. And that gives us, negative cos x pi on 3 minus negative cos of 0. Which, this will be negative half here minus... cos of 0 is 1, so minus 1. So this would be 1 minus half, so this will overall be a half. All right. This would be a half. Done. Hence or otherwise, find all values of k such that this is equal to that, where k is between negative 3 pi to 2 pi. Okay, that's not too bad. Well, we already know this. We've already solved this, and that's equal to a half from the previous question. So we can just write this as half is equal to the other one, which is 0 to, oh no, it's k. K pi on 2 cos of x dx. Let's solve this. So this will be a half equal this bracket. Sine of x pi on 2 k. So half equals sine pi on 2. So what's sine first of pi on 2? So sine pi on 2 is just 1. And we're going to put a minus. What's sine of k? We just write it as sine of k. So we can say that sine of k is just equal to a half. And we need to solve that values of k from negative 3 pi to 2 pi. So what is our base angle? Our base angle is pi on 6. So in which quadrant is sine positive? Well, it's here and here. So your values of k are going to be what? We want it from, okay, 2 pi, negative 3 pi to 2 pi. So your values will be pi on 6, pi minus pi on 6. You can also get negative pi minus pi on 6, and negative 2 pi plus pi on 6. And yes, those are the only 4 ones. So yeah, let's put those to the top and simplify them. And yeah, let's do that. So your k would be pi on 6. This one will be 5 pi on 6. This one over here, which is, this thing of negative 6 minus 1, so negative 7 pi on 6. And this one will be negative 12 plus 1, so negative 11 pi on 6. These are your values. Right over here, these are your values of k. I hope they are right. Again, guys, these are my suggested solutions, so yeah, they could, so students can, just mark their tests. So question 6, let p hat be the random variable that represents the sample proportion of households in a given suburb that have solar panels installed. From a sample of randomly selected household in a given suburb, an approximate 95 confidence interval for the proportion of p of households having solar panels installed was determined to be this. Find the value of p hat that was used to obtain the approximate 95 confidence interval, 1 mark. Okay, this is not too bad. So what you should know is that, okay, when we're dealing with, proportions, what do we know? We know that p hat is your actual mean, the point of mean. And so for example, these over here, these confidence interval will be equal length. So this will be 0.16 here, and this one will be 0.04. There will be equal length from the mean, as you can see. So if I wanted to find p hat, it's just, because we know they are equal length, it's just the addition of these two, dividing them by 2 will give you this p hat, the middle value. So that'll be easy. So we can say that p hat is just 0.16 plus 0.04 over 2. So your p hat is 0.10, or just 1 on 10. Very nice, so 1 on 10. That was 1 mark, nice and easy. Use z equals 2 to approximate the 95% confidence interval. Find the size of the sample from which the 95 confidence interval was obtained. So we need to find the size of the sample size. Okay, so I'm just going to pick one. So I want to pick this one over here. I'm just going to pick this easy one. So I know that would be what? By the formula, it's just p hat minus z, which in this case is 2, is the square root of p hat, minus p hat over n. And I know p hat's 1 on 10. And we just want to calculate, no, and that's all equal to 0.04. Yep, so 0.04. So our p hat's 1 on 10, so we can just write this as 1 on 10 minus 2. This will be 1 on 10, 9 on 10 over n. That's all be equal to, I'm going to make this to a fraction, which is just 4 over 100. So simplifying this much further. So this over here, I can simplify that just by looking at it. It's 9 over 100 over n, and square rooting that, it's just 1 over 10 root n. So this would just become 1 on 10 minus 2, 3 over 10 root n, all equal to 4 over 100. So this here becomes 5, so we can just write that as 1 over 10 minus 3 over 5 root n is equal to, let's simplify that, that's just, let's keep that 4 over 100, just let's keep it. So what's 1 over 10 minus 4 over 100 is equal to 3 over 5 root n. So that'll be 6 over 100 is equal to 3 over 5 root n. Now this over here becomes 1 and this becomes 2. And how many times this can become 2, 20, and this becomes 1. So this here will be 2, 1 over 20 root n. So flipping, those, that will become 20 over 2 root n, which is just 10 root n. So your n value is just 100. There we go. N is equal to 100. Question C. A larger sample of households is selected with a sample size of 4 times the original sample. So 4 times the original sample. Okay. The sample proportion of the households having solar panels installed is found to be the same. So your p hat is the same. By what factor will the installed sample size affect the width of the confidence interval? So by what factor? Okay, we just want the factor. So what I'm just going to do is, okay, our width. What's our width of a confidence interval? It's just this part over here, the square root of p hat 1 minus p hat over n. That's your actual width. So we want to find what factor will be. So by what factor will the installed sample size affect the width of, okay, because we know that with 4 times in the original sample, so this will be 4 times, this just becomes, 1 over 2 square root of p hat 1 minus p hat over n. So what's happened? So this over here is our original, width, and it just becomes dilated by a factor of a half. That's what, that's the factor. It just gets dilated by a factor of a half. So by what factor will the installed sample size affect the width of the confidence interval? And we can say, by what factor? We can just say, I think just factor of half. Yeah, we can just say factor of half. By what factor will the installed sample size affect the width of the confidence interval? Yeah, factor of a half. I don't think, it's just 1 mark, so I don't think you need to write as much. By what factor? Yeah, factor of half. That's it. I hope that's right. Okay, question 7. Consider f from negative infinity to 1 all reals f of x. This part of the graph of y equals f of x is shown. State the range of f. So, okay. Well, f is, shown here. So the range is from negative 2. So we can say the range of f is from negative 1, actually. Sorry, negative 1 to infinity. Yep, so negative 1 to infinity. Sketch the graph of the inverse function of f inverse on the axis above. Label any endpoints and axial intercepts with their coordinates. So, okay. So what I'm going to do is I'm going to just draw y equals x. Right over here. Oops. Okay, something like that. And, okay, I know the points will be kind of interchanged. For example, this coordinate here is 1, negative 1. This coordinate here is just 1, negative 1. So it'll be negative 1 on 1. So it'll be over here, this point. This point will stay the same. Also, this point over here is, negative 1 on 3. So negative 1 to 3. So it'll be 3, negative 1. So it'll be here and here. It'll be this point. So if I'm just drawing this nicely, it will look like this. Like that. Perfect. And we want to label the endpoints. So this will go to infinity, by the way. This endpoint here will be negative 1 to 1. And this axial intercept is 0 to 0. That's it. That's that. 2 marks. Okay, so C, it says determine the equation of the domain of the inverse of f. Okay, so what we're going to do is f already in terms of f of x? Yeah. So we can just say interchange x and y. So this will become, so f of x is that, so it will be x equals x equals y squared minus 2y. Now this is where okay, so how do we get y? Okay, this is just going to be a quadratic. So what we're going to do is, okay, bring that x to the other side. So y squared minus 2y minus x is actually equal to 0. And we're going to solve for y. So by using the quadratic rule, negative b plus or negative b squared minus 4ac all over 2a is going to give us a y value. So your y is 2 plus or negative b squared, which is negative 2 squared, which is just 4, minus 4, 1, c, which is negative x, all over 2. So y is 2 plus 4 plus 4x over 2, so which is y, 2 plus 2, 1 plus x, over 2, so y is 1 plus or negative root 1 plus x, but we reject the positive one because we know that the domain is to the negative, so we have to take the negative one. So your y is 1 minus root 1 plus x. So your, therefore, f inverse of x is 1 minus 1 plus x. And we want also the domain. So your domain, your dom of your inverse, is just a range of the original function, which we already calculated, which is negative 1 to infinity. Negative 1 to infinity. That's, and let's double check it. Yeah, it looks good. So that's that. It should get you the mark. Perfect. So calculate the area of the regions enclosed by the curve of f inverse and the y equals negative x. So if we draw y equals negative x, so this is, oh, oops, let me just rub this out here. I don't like this. Keep this out. We want to draw y equals negative x. So that's going to look like pretty much look like this. Like that. Well, it's not the best, but yeah, as you can see, this here is y equals negative x. So, and we want to calculate the area enclosed. Now, it really can be seen, but the area enclosed is right over here. This area over here. And they are symmetrical, as you can see. They should be symmetrical. Let me just show you kind of how it looks. Just let me redraw it here. So so the green one would look like this. So it's going like this, and this one over here is looking like this. And so the y equals negative x crosses this point over here, and kind of, well, it splits. So it's like this area should equal to this area over here. I really can't draw it, but yeah, if you have the kind of exam paper, you can see that as, yeah, I haven't drawn it as to better scale, but yeah. So what I'm just gonna write is f, calculate the area of the enclosed area. So because they're the same, I'm just gonna find the area of one and double it. So I want to find the area of this because I already know the equation. I already know the equation, the inverse, but I'll use just f. It's much easier. So the top function is negative x. Okay. So from 0 to 1, let's write that down. So from 0 to 1, and we're going to double it. The top function is negative x. So we're going to say negative x minus f of x, which f of x is x squared minus 2x. X squared minus 2x dx. Let's do this. So this will be 2, 0 to 1. This is just negative x minus x squared plus 2x. So this will be negative x squared plus x dx. Let me just rub that out. And so simplifying this, so this will be 2, negative x3 on 3 plus x squared over 2, 0 to 1. So 2 negative 1 on 3 plus 1 over 2 minus 0, but that's quite useless. So that is 2 minus 2 plus 3 over 6, which is just 2, 1 over 6 is equal to 1 on 3, 1 over 3. So it's 1 over 3 units squared. That's your area. Is that right? Yeah, 1 over 3. So question 8. Suppose that the queuing time, t in minutes, of a customer service desk has the probability density function this. For some value of k with element of all reals, show that k is equal to 1 over 64. Nice and easy. So I'm just gonna, we know that it's just from 0 to 4 of the function f of t, dt should equal 1. Yes, because it's a probability density function. So f of t is this. kt, I'm going to just kind of expand it to make my life easier for kind of questions. So 6kt minus kt cubed. So if I was writing this, it's going to look like 0 to 4, 16kt minus kt cubed, dt should equal to 1. So, okay, doing that, so that'll be 8kt squared, so yep, minus kt to the power 4 over 4 should equal 1 from 0 to 4. So now summing 4, we're saying 8k, so 4 squared, which is just 16, minus, minus k, we can write that as just 4 to the power 3, because that 4 just gets out. Yes. Wow, this is such an algebra. So yes, yeah, minus, and you know, putting 0, the other ones will just become 0, so there's no need for that. It should all equal to 1. So 16 times 8, wow, 16 times 8, 45, 8, 9, 10, 11, 12. So 125. Is that right? 45, 8, 12. Okay, so yeah. So this will be 125 minus, so what's 60, so 25k minus 64k equals 1. So, okay, there's a problem with this. It's supposed to be 48. 8 times 48. This is 1 to 8. That's, okay, so it's be 1 to 8. So that should be 64k equals 1. K equals 1 over 64. Wow. Yeah, I can see why the algebra is a problem in this. Just 1 mark for this. Wow. Just has a lot of algebra. Okay, now find the expected value of t. So, okay. That's easy because that's just 0 to 4 x, oh, actually it's t times f of t dt. So I know that, okay, so that's just going to be the integral from 0 to 4, 16kt squared minus k t to the power 4 dt. If I'm not mistaken, yes. Okay, so let's do that. So that will be 16k t to the power 3 over 3 minus k t to the power 5 over 5. Okay, I want to be careful because the algebra here is quite big. Is, okay, from 0 to 4. So that will mean that because we know k. Okay, we know k. So let's just put k. It'll make our life easier if we just do a now then at the end. So because k is 1 over 64, just what's 16 times 1 over 64? That'll be 8. That'll be 32. That'll be 4. That'll be 16. That'll be 2. That will be 8. So it's 1 over 4. So 1 over 4 divided by 3, which times 1 on 3. It's 1 on 12. So it'll be t cubed 12. So for the other one is just 1 over 64 divided by 5, so which times 1 over 5. Okay, that's quite big. So 64, 5, 20, 30, 32. So this will be minus t 5 over 320, 0 to 4. Okay, so now let's sub those in. So the first one is 4, so 4 to the power of 3, which is 64 over 12, minus this one. Okay, I can just say 64 4 squared over 320, because it's very big, I can't be bothered running. So minus, okay, and I'll put the other ones, it's just 0. So okay, just let's simplify this. So 64 over 12, what's that? So if I can halve that, that's 32 on 6, 16 on 3. So this will be 16 on 3. And what's this one over here? So what's first? 64 over 320. All right, wow. Okay, so halving this will be, 160, 32, 16, 80, 8, 40, 4, 20, 2, 10, so 1 over 5. So this will be 4 squared over 5, which is just 16 on 5, minus 16 on 5. Okay, so that is, so what's 16 on 5? It's 30, 5, 6, 7, 8, so 80. So we're saying 80 minus 16 on 3, 6, 12, 18, 18, 34, minus 48 over 15. That's, so 32, so it'll be 32 over 15. Hope that's right. Yeah, I understand why students were telling me that algebra is bad. Wow, 32 over 15, all that just for 2 marks. It's very, very messy. What is the probability that a person has to queue for more than 2 minutes given that they have already queued for 1 minute? So wait. What is the probability that a person has to queue for more than 2 minutes given that they've already queued for 1 minute? So we're saying, what is the probability that a person has to queue for more than, so it'll be, let's say t is greater than 1, more than 2 minutes, given that they've already queued for 1 minute. So what's the point of that 1 minute? Isn't it just t is greater or equal to 1 for that one? Because if you can think about it like this, if I draw a timeline, I feel like a lot of students would write t equals 1. Because if you write t equals 1, then there's no point of intersection. Remember, so think of it like this. If I draw a timeline and says, what is the probability that a person has to queue for more than 2 minutes? So let's say this is 2 minutes, this is 1 minute, and this is 0. Because it's time. And what is the probability that a person has to queue for more than 2 minutes? So more than 2 minutes is here. Goes to infinity. Given that they've already queued for 1 minute. So if they start, because normally they start from 0 and they've waiting, already. If they've already queued for 1 minute, it's just this over here. That's the 1 minute. They've already queued for that. What's the point of that? So yeah, we just look at 1 to infinity. So t is greater or equal to 1. And that's the point of intersection that we want to have from this point of view. So we can just kind of redraw this as that, yeah. So what's the point of intersection? It is probability that t is greater than 2 given the probability that t is greater or equal to 1. Hope that's right. That's how you would, yeah. So, okay, now this is a mess. Okay, that's too much. So probably that t is greater than 2 is what? It's just going to be the integral from 2 to 4 of the function. This, which is, you know, we had it simplified over here. 16 kt. 16 kt, so we can write it as 16 kt. I don't want to write it like that because it's in terms of k. I don't want it in terms of k. I want already. Oh, wow. Okay, that's a ooh. So it'll be the integral from that from 1 to 4 also. Okay. So let's think about it. If I can, because k is a constant, I can just take that out. So it'll be 1 over 64 over here, and 1 over 64 here. It will just be 16t, so here will be 16t minus t to the power of 3 dt. So okay, both will have the same. So 16t minus t to the power of dt. Let's just kind of calculate that. So that's going to be 1 over 64 integral 8t squared minus t to the power of 4 from 2 to 4 over 1 over 64 8t squared minus t 1 to 4. So these cancel out anyway. So let's try to do the top one. So it'll be 8, so 16 minus 16 4 squared over 4 over, oh my god, wait, what's this? Why just so much? Minus 8 4 minus 16 over 4 all over, wow, okay. So if I sub in 4, it's going to be the same as the other one, so 8 and 16 minus 16 4 squared over 4 minus 8 minus 1 over 4. So let's just simplify this. So what's 8 16? 8 48 8 9 10 11 12, so 1 to 8, so it'll be 1 to 8 minus 4 16, so 16 4 6 12 18 24 4 8 9, so 4 8 4 5 6 wow, 64. Okay, so minus 64 minus, okay, 8 16 24 32 32 minus 4. Okay, wow, I'm actually, wow, this is such a mess. So this will be here, this is just simplified 64. So this will also be 64 minus 8 16 24, so 8 16 24 32, so 32 minus 1, so that'll be 31 over 4. So 31 over 4 here, this will be 28. So what's 64 minus 28? That will be 32 plus 4, so 36. So this will be here 36. Then what's 64 times 4? So 4 times 16, 6 12 18 24 24 25 256. So this will be 256 minus 31 over 4. Alright, so that's 200 and, okay, 200 1 9 plus 6, so 225 over 4. So 225 over 4. So what's 36 divided by, so times 4 over 225 this. Okay, let me just rub that out. Let's put that on top. So can we simplify anything from here? Can 36, like, how many 9s can go in 225? So 2, 2, 5, 9, 9, 18, so twice. 45. Yeah. Oh my god. Yes, so 45, so 25, so how many 9s? 4. How many 9s? 25. 4 times 4, 16 over 25. Can we simplify any further? No, don't think so. I don't know if that's right. I actually don't know. That's so long. For 3 marks, my brain's dead right now. I don't know how people will finish the exam at, like, if you're going to think of like that. What a question. So I'm not too sure yet. 16 over 25. And I know if you can simplify further. Hope that's right. Move on to the next question. Question 9. The shapes of 2 walking tracks are shown below. Okay, we can see track 1. Choose that. Okay. Track 1 is described to be a function with this. Track 2 is defined by this function. The unit of length is kilometers, given that f of 0 is that, and g of 1 is that. Verify that a is 12 and b is -3. Easy. So, if we know that, so f of 0 is actually 12. So we're just saying 12 is equal to a minus 0, 0 minus 2 squared, which is just 12 is actually equal to a. That's easy, and we've done that. For the next one, given that we know that g of 1 is equal to 9, subbing, so it'll be 9 equals a minus 1. Oh, no, it's g actually, sorry. What am I doing? So g, so it'll be 9, 12 plus b, so your b is just -3. There we go. We have shown that that's that. Next question. Verify that f of x and g of x both have a turning point at P. Give the coordinates of P. So yes, as we can see, there is a point of intersection at P. So to do that, what we're going to do is, we'll find first f dash of x. So the first f of x is what? It's this. So now, because we know a is 12, so we write 12 minus x. This here just can be simplified as x squared minus 4x plus 4. So f of x is just 12 minus x3 plus 4x squared minus 4x. So f of x is negative x cubed plus 4x squared minus 4x plus 12. So your f dash of x is just negative 3x squared plus 8x minus 4. So which, and we want f dash of x to equal 0 to find the turning point. So that will give us 3x squared minus 8x plus 4 equals 0. 3x, x. Alright, two things that give us 2, so 2 on 2, is that right? And if I put a negative here, no, so if I put a negative here, that will be negative 6 plus 2. No, we have to put a negative for both then. Yep, works now. So 3x minus 2, x minus 2 equals 0. So your x is 2 on 3 and x is equal to 2. Okay, those are the two turning points for that. Oh, it's actually not the answer, but yeah. For what about now so g of x. So g of x, let's write g of x. So g of x is what? 12x. Well, b is negative, so it's negative 3x squared. So let's find g dash of x. So this is 12 minus 6x, and we want g dash of x to equal 0. So what's 12 minus 6x equals 0? X is equal to 2. Because both have x equals 2, that is the actual x value for the point of P. So what is just g of make my life easier? What's just g of 2? That will be 12 times 2 is 24 minus 3 4, which is just 24. 12 minus 12, which is just 12. So that is just 12. So it will be coordinates 2, 12. That'll be the coordinates. That's that. Okay, hope that makes sense. All right. C, a theme park is planned whose boundaries will form the triangle, OAB. Okay, yes, so it's here, O to A. So A is over here and B. Where O is the origin, so A is, K of 0, so K of 0. B is KGK, as shown below, where K is between 0 to 4. Find the maximum possible area of the theme park, so the maximum. So let's just write, what is the area first? So area in terms of X is what? Well, we know the area of a triangle is half base times height, so what's our base? So it'll be half, what's our base? It's K. What's your height? Your height, as is shown here, that B, this one is kg of k, which is just g of k. And what's g of k? So g is just 12k, so it'll be 12k minus 3k squared. Okay, so let's just simplify that. So a of x is k on 2, 12k minus 3k squared. A of k is 6k squared minus 3 over 2k cubed, and we want to find a dash of k, the derivative, so that'll be 12k. So minus 9 over 2k squared. So a dash of k should equal 0. So we want, that'll be k 12 minus 9 over 2k should equal 0. So k will equal 0 and k is equal to, well, what's 12 minus 9 over 2k, which is 12 over 9 over 2k, which is just 12 times 2 over 9. How many 3s? So 4. How many 3s? 3. 8 on 3. So k is 8 on 3. So we have two values. But we know that k cannot equal to 0 because as it's shown that k isn't... Oh, wow, what did I do? So k is an element from 0 to 4 where 0 is not included. So k can only be this one right over here. So we want to find the maximum possible area. So let's sub that in. So what's a of 8 on 3? Let's do that. So that'll be 4 on 3, because it's just 8 on 3 times a half. Yep. What's 12 times 8 on 3? That'll be 4. 8, 16, 24, 32. So it'll be 32 here. Minus 3. What's k squared? So it'll be 64 over 9. So 64 on 9. Okay, so it'll be 4 on 3, 32 minus 64 over 3. So 4 on 3. So what's 32 on 3? So 6, 9. So it'll be 96 minus 64 on 3. Okay, wow. Okay, so that'll be 4 on 3. So 26 plus 6. That'll be 32. So 32 on 3. So 32 on 4, so 4, 8, 8, 4, 8, 12. So it'll be 128 over 9 units squared. That's your area. Hope that's right, the algebra. And yeah, I hope you guys enjoyed this video. I think that was the last question. And yeah, good luck for your exam 2. I hope you guys, smash it out. I hope it's easy for you guys. And yeah, thanks, for some of my students who've given me these questions ahead of time. So I can straight away, smash through this video. And yeah, guys, Good luck. Have a good day. Bye bye.